Welcome to my course on network analysis and agent-based simulation, building networks in which the nodes are agents able in operating in the perspective of the agent-based simulation. As in my classes, I start introducing the links most useful for the lessons. First of all, my personal address, my home page, the repository of all the material of our lessons, and you can verify that online you have a structure where the first lesson is already reported, and each day I will add the new lesson. And first of all, there is the same file of links that I am showing now locally. The second important address is obviously that of NetLogo, but more precisely that of the GitHub, where the extension NW related to networks is reported. Installing NetLogo, you have also locally the extension NW, but the documentation is more interesting in the online GitHub. I underline that we had already an extension of NetLogo related to networks, the networks extension, but quite recently, 2 years ago, they added this new, most powerful extension. Then we have the address of Python, but most important again, the address of the NetworkX Python library about networks. Here again we have a GitHub in the IO version, and from here you can have the access to the documentation and to the library in the different formats to be downloaded. Then we have the link to SLAP and to the handbook related to SLAP. SLAP is my shell that I have deeply introduced in the previous course about agent-based simulation, built in Python following the protocol of the important root of all the modern simulation agent-based tools, named Swarm, the product of the Santa Fe Institute for Complexity Studies in the middle of the 90s. All the previous agent-based course is reported in this container, and we have also online lessons. This is a library related to Python and complexity. We will pay time for examining it. And finally, this is a channel of myself in Scoop, where I collect material about complexity and agent-based simulation. The Scoop tool is simply to be used when we find an interesting website. We can introduce it directly in the channel on Scoopit, as you see here. This journal, and I am one of the founders of the journal, is close to publish 1 year from now a special issue on complexity policy and economics, where agent-based simulation can be considered a very important tool. So you can also think about the possibility of preparing a paper for this special issue. And with this last address, I have concluded the presentation of the basic links of our course. Second step, the evaluation will be based on an essay. Sure, your effort in doing the works is deeply appreciated, but the evaluation is related not to the works, but on the final essay. Here you have the content and the requirements. The deadline is January the 10th, in a not absolutely rigid way, but I hope you will respect the deadline. We have our timetable. You already know it. 2 lessons in the first week and 3 in the second one. All will be online, both as videos via YouTube and with all the material in our repository. No more starting information, but the main goal of our course, and the main goal is connecting agent-based simulation to network analysis, building network arising from the behavior of the agents. Network is used in different perspectives, and I suggest to you to have a look to this small collection of Wikipedia links. The first one is about disambiguation. The second one is about the definition of social networks. The third one is applying network analysis on social network. And the third one is related to complexity and networks, underlying the importance of scale-free networks, where the scale is not relevant about the characteristics of the network, and the small world networks, where a very slow number of links is sufficient to create a fully connected network with all the agents related among them. Stop about this part, and I jump to the first day material. Here we have the content, and the content is first of all related to a paper of Magda Fontana and myself, and the paper is a project in the agent-based and network analysis perspective. Then we will jump to NetLogo and to the basic contents for an introductory phase in the use of networks with NetLogo. Finally, we'll examine in the GitHub of the extension at this address 2 important concepts, that of context, so the collection of the agents of the links we are looking at, and the definition of special agent set versus normal agent set, a quite complicated small detail in NetLogo. Then we will have a look to a demo version of the network extension, and finally we will conclude this conversation jumping to the online version of SLAP to look at the production model, which is strictly related with the idea of this first look to the production world, an idea of mine, where I am developing the capability of an agent-based model to move not only agents but pieces of information among agents, and the effect of these pieces of information will generate the network that we want to study. Let's underline, to conclude the presentation of the content, that this link to the MyBinder project, where an online material reported in a GitHub is directly executed, is an explicit link, because from here GH means GitHub, Terna is my repository in GH, SLAP3 is within my repository the folder of the program SLAP, master is the branch, and in a GitHub, or generically in a Git, we can have several branches. Each branch is different as content, but they are all consistent. As an example, here we have the master, but other branches are all previous versions still important to be conserved and to be modified, or developing versions. When a developing version is well working, we can merge it in the master and have again a new completely filled structure of our project. Go back. The starting point is the presentation of the ideas of a project to explore the capability of the networks if they are built upon agents. And here you have a presentation of the paper. I will move quickly within the presentation. And first of all, the starting idea. Why to pay so much attention to networks and to agents within networks? Mainly because we want to generate tools for policy making in the very complicated new democratic structure of our states. Political action is very difficult. This is the main premise to the presentation, because on one side we have more and more complicated problems as the complexity of our societies is increasing, and on the other side we have a lot of difficulties to manage this problem, both from the side of the political actors and from that of the citizens that are expected to choose the political actors with their votes in an environment always more and more complicated. If we are able in simplifying the problems but always keeping alive the sophistication of the modern society, we can help in creating a dialogue between political actors and citizens, and can be a mission of our models with networks and agents, mainly opening the behavioral black boxes of the real world agent, not of the artificial one, to understand how to act and to provide political choices. The first step is quite easy. Imagine to create a world where informations are set of recipes. A recipe is a set of instructions for cooking food where you have quantities, qualities, parallel actions, sequential actions, phases of the preparation, and so on. In industrial economics, they use the same name, recipe, which is coming from the old French, and the pronunciation is not recipe but recipe. They use the industrial economics recipe as cooking products instruction. So in industrial organization, we are not preparing food, but we are preparing goods, merchandises, actions, sequences, supply chains, organizations, and all can be described as sequences of steps. In this case, the steps are numbers, but we have also put here labels, literal constant values, to better explain the sequence. In this case, the recipe means, first of all, execute the step 3. Okay. Then the step 1. Then the step 7, and so on. The actors here are producers, and we can imagine them as factories. Producing water, here you have a list of possible applications, but the limits are only in our fantasy. Each step can be complicated as we want, and within a step we can have another set of recipes. A very complicated implementation of this idea is in my website. If you look at the JES page, JES, Java Enterprise Simulator. It was a layer of Java upon the Swarm project. The Swarm project is the shell for agent-based simulation created in the middle of the 90s in the Santa Fe Institute. Quite recently, a scientist has regenerated the possibility of easily running Swarm via a virtual machine, and next week I will show you the project with the virtual machine running it. Now we start with a simple NetLogo program, and you have a look here. This is the world. In the world we have an abstract place where orders arise. They are coming from the market, but we don't explain the market. Simply we receive from outside our simulation the orders containing the recipe describing how the order have to be produced. We have factories, orders are moving from a factory to another to accomplish the different steps of the recipes and are generating a network. The network can be pruned, deleting a few links, the less important one, can be shown both as a circle or as the original space. Imagine this is a geographical space. And what we obtain? We obtain a less or more complicated structure. This is created with SLAP, so in Python, we will see it running also online SLAP. And this is the starting point to reach the second step. In the second step of the project, remember that this is a paper related to the project, we have first of all actual life agents, entities related by links or edges. With agent-based simulation, we build the agents. With networks, we link the agents, and we try to have C closer and closer to A, but we know A. C is useful to simulate with different hypotheses the effects of the structure A. The third step is more difficult because we miss the possibility of knowing agents, so of building the agent-based model, we have to jump directly to the artificial agent-based model with the network because we know only network effects of the behavior of the agents. Imagine to have a set of tweets and from there try to extract, using as an example sentiment analysis, the effects of the tweets on the behavior of the stock market as happened in China a few months ago where two different crashes were preceded in a clearly way by the change of sentiment in the tweets related to the Chinese stock market. Online from my website you can look at a thesis related to this kind of analysis. Going back again to the presentation, from C we want to make inference to D, so a running model where you can try to explore different hypotheses on the behavior of the agents in the network. Finally, we can try to go back from our artificial structure back to the known one, and from the known one to try to make inference on the agents, always in artificial models, and again back on the actual structure of the agents in a network. This is a very ambitious problem. It is in some way a dream. Currently, the possible activities are reported in this table, but this is a huge project to be accomplished. Now I have to conclude my project on the oligopolistic market, but as it will be possible, I will be back to this project considering network analysis as a tool connected to agent-based simulation. Now we move to the examples in NetLogo, starting from the first exploration of the network extension. The first step is that of looking at a very, very simple example, our first NW example in NetLogo. And here you have the model. The model is a static one, We don't pay attention here to the time, only to the picture of a frozen, about time, situation. With create, we generate a network. We can simply change the network. And how it is generated? Here you have, let me increase a bit, the NW extension included in our code. We generated the create procedure, creating 3 turtles and asking to the turtles to create links with other turtles. This other is very important because creating links with will try to create auto link from the turtle to itself. This is forbidden in NetLogo. And then we move randomly in our space the agents. Then we generate the context. The context is the main idea, the key structure of the extension NW. When we make a calculation upon the network, the formulas look at the content of the context. This is a little problem of words. Content of the context. The context is the definition of the elements of the network we are studying. We can investigate the content using map to apply the sort function, which is ordering the content of a list, to the sublist turtles and the links of the context generated here. And you can explore the effect here. This is the network, and here in the command center we have the effect of the show, the 3 turtles, number 0, 1 and 2, and the links connecting them. You can verify that the links have both the directions. We don't have here a 1 to 0 link because using with, links have no direction, and the link connecting the agent 1 to the agent 0 is also connecting the agent 0 to the agent 1. Let me introduce a small modification. I write here 2, so the link is from an agent to another one, always with the other to avoid autolink. The effect is dramatically different. You see now that we have always 3 agents, but the links are now 6, from 0 to 1 and from 1 to 0, from 0 to 2 and from 2 to 0, and etc., from 1 to 2 and from 2 to 1. And if I double click here on a link, let me increase a bit the presentation. In this way, if I click here, you see that we can inspect 2 different links, and we have 2 arrows. This one for this direction and this one for this direction. This is sufficient as main introduction. The second step is related to examples of. No, let me introduce a second introductory example, the very simple one. Why? To show you the effect of the parallelism. Here we generate a network with nodes, not yet structured agents. They are agents, but they have no capability in action. And then we move the network, moving the agent. You see that apparently all is moving instantaneously in a parallel way. If we decrease the speedness of the presentation, you see clearly that this is a sequence of events and the links are adapting to the movement of the nodes. Stop for this detail. And now I move to our more structured context explanation. This is extracted from the online handbook of NetLogo Network Analysis extension. At this address, let me open a browser to this address, and you see that at the bottom of the list of the files that represent, contain the content of the GitHub about NW, we have the explicit presentation of the README MD Markdown language file, and the first element introduced here, after special agents and normal agent, I will explain that, is the idea of different context. And the context are shown with an example where we have agent, their friendships, and the account of the agent with bankers. Here you have the example, here, and here the implementation. In the code, we have two breeds and two types of links. One defined friendships in the undirected form, and one defined accounts in the directed one. Here we generate bankers and clients, then we move around both of them using the super definition of turtles, because these are all turtles, and then we create the links of the two types. Finally, we generate different context using a chooser. This is a chooser. If I edit it, you see clearly the different possible values of this chooser. And as an example, here we have client's account. I generate the network and I create this context, and you see that the content of the context clients accounts, let me increase also this view, is all the clients. The client starts with 3 and finishes with 8, and all the accounts, the account of agent 3 with bank 1, of agent 4 with bank 1, with all the possible couples of agents clients and agents account in banks. But the true agent is the bank and the account is the link. Let's check as an example here. Here I have a 1 to 3 friendship link, a 3 to 6 friendship link, a 3 to 5 friendship link, and an account from agent 3 to bank 1. And we can inspect as an example this account is this violet line, and here we have all the data, because also the links have agents, are agents with all the attributes of a normal agent in NetLogo. Now let me underline the importance of the difference between special and normal agent set. This definition here. What's the problem? If we have a breed, as we add an agent to the breed, all the code will be acting on the new set. This is a special agent set. The special agent set are the native one in NetLogo. Instead, if we modify the content of an agent set generated not by NetLogo but by ourselves defining as an example a variable, a global variable, and declaring a set my collection of people with lenses, and we set this collection from turtles with lenses true or simply with lenses if lenses is a true false variable. This set, number one, is static. The first one, the special one, is dynamic. And the code will continue to pay attention to the first definition also if we define a new agent with lenses, because when the variable was linked to the set of the agent of lenses, being this definition static, that agent new with lenses was not included and automatically it will be not included. We have to pay a lot of attention, reading carefully this introduction, because a lot of error can arise from there. Now we move to a quick look to a special old demo coming from version 5 of NetLogo. This special demo is not interesting. They have eliminated it. I don't know why. It's very interesting, more than for the content of the code or of the interface, for the wonderful content of the info sheet. The info sheet contains a quick handbook about networks with a lot of different links. Links to what? To definition. As an example, I want to calculate a special centrality, the so-called eigenvector centrality, and here I have from GitHub, from Wikipedia, the definition of eigenvector centrality. And I have a lot of trust in the computer science and mathematical definitions of Wikipedia, because the community pays a lot of attention to the content of these pages, and rarely you can find the warning this page is to be improved with the links, explanation, and so on. I have extracted from the old versions of NetworkX, of NW extension, also a cheat sheet prepared by NetLogo people, where you have a short collection of the main functions and orders of NW extension. I forgot, to underline, let me go back to our first, to underline that using instruction from an extension, we have to precede the definition of the keys of the extension always with the name of the extension. You can see it here. So set context is an instruction of the extension, and we have to write it preceded by NW colon. Always, also here, you see, is the same. We cannot link this context to a local variable and have another context. Contexts have to be modified on the fly while the program is running to have different contents. And in this way I conclude the first part of the lesson, just a short stop to save the file.